In this video, we're going to talk about how to solve geometry probability word problems. So let's start with this example. If AD is 20, AB is 8, and CD is 7, what is the probability that a point chosen at random on segment AD will be located on segment BC? And let's say in the picture that all the points are listed in alphabetical order. So this is point A and point D. And let's put B and C somewhere along this line. So we're told that AD is 20 units long and AB is 8 units long. CD is 7. So BC has to be 20 minus 8 minus 7. 20 minus 8 is 12. 12 minus 7 is 5. These three numbers have to add up to 20 because AD is 20. Our goal is to find the probability that a point chosen at random on this segment will lie somewhere on segment BC. Now, when calculating probability, the probability is equal to the number of successful events divided by the total possible outcomes. But for lines and segments, the probability will be equal to the length of the successful line, where you want to find the point located on, divided by the total length. So the point will be chosen somewhere between point A and D. So the total length is 20. And we want to get it between B and C, which is 5 units long. So the probability of finding a point on BC, it's going to be 5 over 20, which you could reduce it to 1 over 4. So this is the answer. So knowing that, what is the probability that a point will lie on segment AB if a point is chosen at random on segment AD? So what's the probability of getting a point in this region out of all the points in AD? So AB has a length of 8. The total length is 20. And so the probability is going to be 8 out of 20. And then you can reduce it. 8 is 4 times 2. 20 is 4 times 5. So we can cancel a 4. And so the probability of selecting a point at random on AD that can be found on AB, that's going to be 2 out of 5. So it's based on length for these types of problems. Now here's another similar problem that we could work on. Point R is randomly chosen on segment AC. What is the probability that it is chosen within 6 units of point B? So keep in mind, the probability is going to be equal to the length of the segment that we want to choose a point in divided by the total length of where we can actually choose the point. So point R is randomly chosen on segment AC. So therefore, it has to be somewhere between AC. That's the total length. To find the length of AC, take the final position and subtract it by the initial position. So it's 7 minus negative 5. So segment AC is 12 units long. So these numbers represent the position on a number line and not the actual length of a segment, as in the last example. So now that we have the total length, we can now calculate the probability. Now we want to find a probability of choosing a point that is within 6 units of point B. So how much is that? Now 6 units to the left will take us to negative 3. 6 units to the right will take us to position 9. 3 minus 6 is negative 3. and 3 plus 6 is 9. However, point R has to be on segment AC, and 9 is outside of segment AC. So you can't say that we want to choose a point that is 12 units left, 6 on the left, 6 on the right, because we have to stop at point C. So therefore, we can only choose point R can only be 6 units to the left and only 4 units to the right, because it stops at point C. We need to choose it. It's going to be chosen on segment AC. So therefore, we want it to be anywhere from position -3 to position 7. So 7 minus -3, that is 10 units long. So the probability of choosing some random point R within 6 units of point B, but on segment AC, is going to be 10 out of 12, which you can reduce that. 10 is 5 times 2, 12 is 6 times 2. So it's 5 out of 6. That's the probability. Number 3. Point X is randomly chosen in the rectangle shown below. What is the probability that point X will be located within the triangle? So in this case, we have a two-dimensional object, so we need to deal with area. To find a probability, we need to find the area of where we want the point to be in, that's the triangle, and divide it by the total area, which is the only possible place point X can be, which is somewhere inside the rectangle. So basically, the probability is going to be the area of the triangle divided by the area of the rectangle. So let's calculate the total area, or the area of the rectangle. The area of a rectangle is length times width. So in this case, it's going to be 10 times 6, so it's 60 square units in area. Now let's move on to the triangle. The area of a triangle is 1/2 base times height. The base of the triangle is 6, and the height is 5. Half of 6 is 3, and 3 times 5 is 15. So the probability of finding the point within the triangle where it has to be somewhere in the rectangle is going to be 15, that's the area of the triangle, divided by the total area of the rectangle, which is 60. And 60 is 15 times 4. So therefore, the probability is 1 out of 4. So for two-dimensional objects, the probability is based on area. For a one-dimensional object, which is basically a straight line, the probability is based on length, how long the segments are. And if you have a three-dimensional shape, the probability is based on volume. Point X is randomly chosen inside a cube with a side length of 12 inches. A hollow sphere with a radius of 5 inches is located inside the cube. What is the probability that point X will be chosen inside the sphere? So let's draw a cube. Now we have a sphere inside the cube, so I'm going to represent that as a circle. So what is the probability that point X will be chosen inside the sphere? So because we're dealing with three-dimensional objects, the probability is going to be based on volume. So it's the volume of the sphere, which is where we want to find the point, divided by the total volume, which is the volume of the cube, because point X has to be somewhere in the cube. But we want to find the probability that it's inside the sphere instead of outside the sphere. So this is the equation we got to use for this example. Now the volume of the sphere is 4/3 pi r cube. And the volume of the cube is basically the side length raised to the third power. Now we have the radius. The radius is 5 inches. And we have the side length of the cube. It's 12 inches. So this should give us the answer. So if you type it in exactly the way you see it, as a decimal, you should get 0.303. So that correlates to a probability of 30.3%. So that's the probability that a point chosen at random within the cube will lie inside the sphere. So what about outside the sphere? Well, it's going to be 100 minus 30.3. So basically, the probability of point X lying outside the sphere is going to be 69.7%. Because the total probability has to add up to 100%, which is equal to 1. Now the equation works this way for the second part. The probability of finding point X outside the sphere is the volume that's outside the sphere but inside the cube. So that's the volume of the cube minus the volume of the sphere divided by the total volume of the cube. So that's going to be s to the third minus 4/3 pi r cubed over s to the third. Now if you're going to type this in, make sure you enclose the numerator in parentheses. So let's make sure we get the same answer. So if you type it in correctly, you should get 0.69699, which you could round that to 0.697, which is 69.7%. So that's how you can set up the equation if you want to find a probability of selecting a point that's inside the cube but outside the sphere. So you got to find the volume that's outside the sphere, which is the difference between the volume of the cube and the volume of the sphere. So that's it for this video. Hopefully this gives you a better idea of how to find the probability for geometry related problems. Thanks for watching.